Hi friends, myself Tarun. I'm currently pursuing a BTech in CSC with Artificial Intelligence and Data Engineering in a lovely professional university. So today I'm going to explain one of the fundamental data structure, stack. So what is stack? Stack is a linear data structure that allows the last in first out LIFO principle. So uh, in this data structure, it's like a stack of plates where you add or remove the topmost plate and doing operations in stack. So moves towards the properties of stacks. Stack in data structure and algorithm have several key properties that define their behaviors and utility. So, stack allows to the last in first out LIFO principle. That means most recently added element in the first one to be removed, and stack provide a limited access, typically allowing operation only on the top elements, such as pushing new elements onto the stack or popping existing ones of it, the last element deleted by the pop operation. So implementation of stack in Python. First is empty operation. Is in this operation it returns true if the stack is empty, otherwise it returns false. Second operation, push. Add any item to the top of the stack by using push operation. Pop operation, remove and return the item from the top of the stack, removing the last element of the stack. Peak operation, return the number of element in the stack. By using peak operation we can find how many number of elements in the stack. So today my topic is Cafeteria Cafe. One of the real life example of the stack is, so in cafeteria scenario, when plates washed and placed back, there are added on top of the existing stack, and push op and we use push operation in stack data structure. When someone take a plate, they usually grab the top one to the and the pop operation in the stack. This reflects the last in first out principle, where the last plate put on the stack is the first one taken. Accesses to plates is limited to the top one without disturbing the rest, similar to how stack data structure allow manipulating only at the top. So features of the stack using cafeteria scenario have key features such as we using push operation, pop operation. Peak operation is empty operation, where in push operation where the new plates are added on the top, and in the pop operation where the plates are taken from the top. This reflects the last in first out principle, LIFO principle, where the last plate placed in the first one taken. So which operation we used in stack? Operation 1, push operation. By using push operation, new plates are added on the top of the existing stack, representing the push operation in stack data structure. Pop operation, when a person take a plate, they take the one off from the top of the stack. So we use pop operation. By using pop operation we remove the last element of the stack. It follows the last in first out principle. The stack of plates follows LIFO principle, where the last plate placed on the stack is the first one to be taken off. First plate, last plate will be taken out first one. So next, move towards pseudocode of today's topic. For pseudocode, we have to define a stack structure for plates. For that we have to initialize an empty stack by using is empty operation. Then when a customer finish their meal, if the stack is not full, so add the plate to the top of the stack by using push operation. We have to add the plate to the top of the stack. Else notify the customer that the stack is full and then can't leave their plates. So next, when a staff member collects the plates, if stack is not full, so remove a plate from the top of the stack by using pop operation. We have to remove the plate from the top of the stack. Else notify the staff member that there are no plates to collect. All plates were collected. So move toward coding part. So firstly we have to make a class stack, then using def operation we have to use constructor here init to initialize the class stack is self items equal to empty. Then another def is used for is empty operation. Return is equal to empty list. Then another def for push operation. In this we have two parameters, self and item. Here we have to add items by using append function. Then print item to this stack. Then other def for pop operation which is used to remove the plates from the last of the stack. If not self is empty, self dot is here pop allows the user to remove the top value from the stack. So if self is empty is not empty, then it return self dot items. Else it print stack is empty. Then next function is pick. Here pick allows the user to see what values on the top of the stack. So if note is empty, note self dot is it return last element of the stack, else print stack is empty. Then last operation for this code is size. That allow the user to find the number of element in stack. Means len of the stack. We have to make menu driven for this stack. If while true, then print \n is used to put element in new line. First is push operation. Next pop. Next pick. And last is size. then stack is quite. Here we take choice variable fuse to enter the choice. Then use if choice is equal to 1, then it here enter item to push. If choice equal to 1, then it operates push operation. If choice equal to 2, then if choice equal to 3, then use peak operation. We use peak operation to allow the user to check value of the top of the stack. If top item, then print top item is then last operation is search. If choice equal to 4, then print size of the stack. Print size of stack. choice is equal to 5. Then print exit from the program, existing program. Else print invalid choice. Choice. Try again. Please try again. So it's time to run the code. Enter choice. Firstly we have to add element in the stack, so add any number, then choice equal to 1. Add list of element 42. Then enter choice equal to, here elements are added to the stack, then we have to use pop operation to delete the element. Here firstly we have add 121 to the stack, then 132 to the stack, then 142. Then we used pop operation. Pop operation removed 142 from the stack. Then we move towards peak operation, which allow to see the value of the stack. Third, top item of the stack is 132. Then fourth operation, size of the stack, it allow to size of the stack. Size of stack is 2. Then quite exist from the program. This is all for today. Our code is run smoothly